Hello, everyone. Welcome to CTF Radio. In a shocking turn of events, we are now recording 2 episodes in less than a span of the week. So that is, I think, a record for us. So, Jan, why don't you say hi to the people?
Hello, hackers. Great to be here again. It just feels like nothing but podcast recordings in my life right now, which is awesome.
So that
I love the camera.
You don't actually, I was going to say, or you just don't work very much. Maybe that's what
right.
it is. It's just life, living, and podcast recording for you.
Podcast recording, paper deadline. Podcast recording, paper deadline.
Nice. That's great. Yeah, you submitted, 3 papers within the span of the last time we talked? Is that correct?
4.
4?
Including one first author paper, which is something that professors just typically don't do.
Unless they have something to say or a statement to make, I think is the main.
Yeah, exactly. This is very different. It is just a paper to write. And when you're first author and there's no professor with you, you have to write every word of the paper. There's no one else.
Nobody's going to write that paper for you. You got to write it yourself. Oh, man. All right. So we are super excited today. We want to dive right into it. We have our first of a non-shellfish team that we're going to be talking to about the AI Cyber Challenge. Because we've already had now, I think this is the 3rd or 4th episode in a row, we're talking about AIxCC. We are not going to talk about that at all, like what the background is. So if you want background on the AI Cyber Challenge, please listen to our past episodes, which of course I'm sure you all have. So we are now I guess the very first question, and of course the thing I should have done before we're starting this, recording this episode, was to understand how to pronounce the team's name or to say the team's name. I'm going to go ahead and say it's A Beyond Bug. Is that the correct way to say the team name?
Our name is actually 42 Beyond Bug.
Yeah, but is it hex? I mean, 42 is
Yeah, the reason that we take 42 is because there was a book called Guide to Galaxy, and some of my teammates like that book a lot. 42 is the answer. It is the ultimate answer to the universe, so we take that one. So
beautiful.
Yeah, even like our logo only have 42 without anything, so we want to call us 42. Okay.
All right, great. Team 42 Beyond Bug. There we go. So I thought it was like a hex encoding, but now this makes much more sense. The Hitchhiker's Guide to the Galaxy is one of my favorite books as well. So really great team name. So we have 42 Beyond Bug here with us. So we have 4 folks from that team. Why don't we, Xinyu, why don't you start us off, and then we'll go around and everyone introduce yourselves. Maybe give us a little bit about your background and what your role is on the team. We'll start with.
Sure, I'll go first. My name is Xinyu. I know my name is super hard to pronounce, but because it starts with X, there are barely much English word that could start with X. So X pronounced as SH, so it's Xinyu.
But it's awesome. You're Professor X.
Yeah, thank you. So I am associate professor at Northwestern University. I am the leader of the team and basically coordinating the efforts and decide the strategy for the team and helping some of the design of the system and coordinating with DARPA and other teams. That is basically my role.
Nice. Awesome. Ziyi, why don't you go next?
My name is Ziyi, and you can just call me Roland or Z, both okay. And my role in the team is developing and design the program repair agent. And we need to automatically repair many different kinds of bugs. And also we develop some kind of like a patch deduplication component, so we can try to cross-validate if there is a patch that can fix multiple bugs.
Awesome. Great. Welcome. Dang, how about you next?
Hey, everyone. My name is Dang. You might also know me as Midas from some of my blog posts, maybe. I'm a second-year PhD student at Northwestern, and now I'm a member of 42 Beyond Bug. So for AIxCC, I work on a few components. I do seed generation for fuzzing and bug triaging. So basically before fuzzing and after fuzzing. I also make some contributions to the whole infrastructure of the system. I am the main one who does the testing of the system.
Oh, yeah, that's a big deal. Testing is a big deal. That's a huge part of it, as we know. Great. Well, welcome. Xinqian is.
Okay. Hello, everyone. My name is Xinqian. Yeah, it's also very hard to pronounce it.
I did my best.
Yeah.
I'm sorry.
Okay. And also a PhD student from Northwestern. In the AIxCC competition, I mainly do in several components like seed minimization and submitter and do the server evaluation and also have some test works. Yeah.
Awesome. Awesome. Well, very happy to have you. And we're a couple weeks out as we record this from the submission date. So I guess the first question before we dive in, you guys did submit, right? Otherwise, I guess you probably wouldn't be here talking to us.
We do. We did.
All right, great. Yes, you submitted something, right? That's I think the whole goal of every team is just submit something.
Yes.
Awesome.
There's the famous case from the Cyber Grand Challenge where a team that just submitted something that connected to the infrastructure and did anything small and then ceased to function would have done quite well.
Really?
So yeah, just showing up is half the battle. It's just like that Eminem song with the spaghetti thing.
I'm not sure. I don't know if that's the theme
Maybe
of
it's not
that
the
song,
exact
but
takeaway, but
yeah. But
maybe we can have
anyways,
Eminem on the podcast next and ask him.
Sure, that'd be great. Marshall Mathers, we have a standing invitation. You want to talk about capture the flags or any other types of things? We'd be happy to have you. Cool. Okay, so then you've been spending, to give slight background, 2 years building this system. You guys were also one of the small business track teams. So you submitted to that, you won that, and then you qualified as top 7, and then have spent the last year building your finals. So talk to us about does 42 Beyond Bug have 42 team members? I feel like that would be good synergy of just.
Yeah. So our team most of the team member are grad students and university faculties. And one of the common thing for the team members are majority of them are my students or my former students. So yeah, when I heard about this competition, I started to reach out to the people that I know. I was trying to reach out to you guys as well, but I know like you're gonna compete. So so I reach out to some people and they say, oh, we are interested in this, and then we form a team. We have at the very beginning, we have a large team, really, really a lot of people. We have nearly like, if I check my Slack channel, we have almost like more than 50 people at the very beginning. But like when you have a big team, it's hard to manage, and not all the people have the same schedule. It's hard to contribute, therefore, along this journey. So the team size shrinked with only a few key member or core member into it. So until the final, we have about 15 people, around 15 people who commit the code or participate in all the meeting, writing all the documents and decide what strategy we use. So we have about 15 people eventually. So that is about the size of the team.
Wow, great. Okay, so then when you said universities, so what universities are involved?
Yeah. So I would say like most of the students and the faculty come from Northwestern University, and we also involve some other faculties and a grad student from other school. For example, we involve University of Waterloo in Canada. So they have really good, expertise in kernel, in semifinals. So they help us a lot. And we also involve professors from University of Utah, which is very close to Arizona. So they also part of the team. And we have students from there. We have faculty from Utah. We also have faculty from New Hampshire. And because they have good knowledge about Java, because the competition, Java is part of the competition, none of us in Northwestern know Java that much. So we get a lot of help from them as well. So we also hire some programmers. One more university.
Wow.
I forgot that.
Yeah.
So we have one faculty from University of Colorado and Boulder, and he's also part of the team. He has a lot of experience on the exploitation, although exploitation is not part of the game, but some of the expertise like static analysis things could help. So we also bring University of Colorado. So this is basically the whole team. In addition to that, we also hire some programmer, not too many, mostly from the industry. They have industry experience because when we are building the system, sometimes we need some industry engineering experience to help.
Right. Yeah. Wow. That's super cool. So, yeah. So pretty, I don't know, sprawling isn't the right word, but large team with a number of universities that are participating, right?
Yes.
Wow. Very cool. And I guess the funny thing is we talked with the Shellfish team, so I'll try to make some similarities for people. We also had about 15, 16 kind of core members of the team, but the larger team is probably in the 30s or 40s, just like you said, you have other people that wanted maybe to do one thing or one part and wanted to contribute, but not necessarily couldn't commit to doing this kind of full time.
Yeah, it's interesting how there's a kind of convergence there in team design. I think on what we also saw in the Cyber Grand Challenge as well, if there are university teams, both the makeup of the team and the size of the team, they're much more flexible, which is an interesting sort of property of universities in general.
That's true.
Yeah, exactly. It'll be really interesting when we talk to the other teams to see if like academic teams tend more towards this kind of strong core with like other, people still affiliated, or if they, I don't know. I think that'll be super interesting. But on the topic of diversity in designs, maybe would you like to introduce to our listeners your cyber reasoning system? So what's the name? What's like the 1,000-foot overall design look like?
Sure. I think I will pass that to Dang because Dang is doing testing, so he has shared the same knowledge with me. Dang,
I feel your pain. That was what I got roped into for quals was writing. It was right about this time. It was right before the 4th of July. They were like, professors, we don't have anyone who's building a testing system, but we don't have any bodies. And I was like, I guess I'll do the CI and testing infrastructure. And I just spent like 4 days figuring out how to even run their system. But then by the end, I actually did know most of the components because you have to. So please tell us.
If only there was someone that kept saying testing, 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 testing.
Okay, so I'll introduce about our system. So I believe our system is named Bug Buster. We don't use that name very much internally. We just use it for, I guess, in the documentations and stuff for DARPA.
Wait, you have documentation? Yeah. Oh, for DARPA.
Yeah. So like our design, we combine traditional methods and LLMs. We don't try to use only LLMs. So we have fuzzings, we have static analysis, but we also have LLMs in patch generation, seed generation. So the philosophy of our system design in the final is quite different from the semi-final. So for the final, we focus on making it stable and do testing very early. I think that is the key principle of us in the final. So we try to keep it not simple. It didn't end up simple, but
as simple as possible, maybe.
Yeah, we try to make it not too complicated. Like we don't try to come up with fancy ideas with LLMs. We don't try ideas that we are not sure 100% that it would work properly. So we don't involve LLM in like critical tasks. So LLMs, it plays more of a supportive role for traditional methods. So we use it to generate seeds so that it can help with fuzzing. So fuzzing is a traditional method and LLM generates seeds to help it. The reason for that is we don't want like LLM shenanigans, hallucinations to ruin the entire pipeline, right? So if it generates a bad seed, then well, whatever, that seed is not going to contribute much, but it doesn't ruin the fuzzing. For example, in patching though, we do need to use LLM as the core. And so we build a lot of validators and strategies around that to, again, minimize the possible issues with LLMs. Ziyi might know more on that. He can elaborate on that later. But yeah, testing is the main thing. We did testing very early, even before the first exhibition round. Before DARPA even gave us the integration test project, before they gave us any testing APIs, we just come up with our own data set. We put a lot of efforts in preparing our own data set and do a lot of testing on that, like all the time. Basically, we always have some tests running, and when we introduce new features, we just kill the current test and test again.
Nice. So who drove that focus on testing?
I think Xinyu, like at the very beginning of the final round, like he told us that okay, he wants this to be like we focus a lot on testing. We want it to be stable because in the semifinal we tested our system for like 2 days. that was pretty terrible. But yeah.
Yeah, so I want to add something about the testing.
Mhm.
So, basically, if you look at the industry software, when you do the release, at least you could have your engineer sitting behind. When something bad happens, you can go and intervene. But this competition is totally different. So there's zero intervene that you can involve in the whole process. So therefore, testing is super duper important. So that's why when we are developing this, so we want to put more efforts and allocate more budget on testing. So this including like preparing the test cases, having the people to take a look at the code, and also run it in a large scale. Because if we are talking about like only a single machine, that is easy. But if you talk about a large budget and running this in parallel, that's a totally different story. So we spend a lot of time on that. We also spend a lot of money on that. But still, I have to say, like even putting all this effort, there's no guarantee there is no bug that will influence the performance of the CRS system. So we don't know that yet, but I'm very, very, even though we put a lot of effort, I'm still very worried about something could happen with the system that can completely break the whole pipeline and even like making the mistake. I'm not surprised if I see that when I see the final results.
It's always in the wrong direction, right? So you very seldom have a bug that will make everything better suddenly. There was a bug, and so we found 1 billion bugs and fixed all the things, right? It's just somehow it always makes things worse, which is unfair.
And it kind of goes into like, we were, I think with the captains of Shellfish, we were having them guess, what place they would get or whatever. But even as we were doing that, I was thinking like, but it all depends on what the challenges are, what, random, somebody's CRS hits a random bug in a project and then it's just out for that one target. And so that could happen to any CRS. Like there's such crazy behavior that it is, it's building something that works even some of the time is impressive.
One thing that I learned from the semifinal actually is like, in the semifinal, we can see like who find the first block, which team find the first block. And so I know like the 12Bs is doing really, really good at the beginning, and then we catch up quickly and we go in parallel. And later on, when at that time they call it the CP, which is the program, the challenge that they give us. And when the new CP come up, and we never ever see that, I see like the 12Bs and us like completely shut down. And I don't know I cannot say about the other team, but after we diagnose, realize, oh, our system dead. We see
Wow.
new target. But some team I know like they are doing very, very stable. You can see, for example, like Theory, that team I see like they are very stable, growing. Although they don't get the first block, but they are very stable. So stability, that is my hunch. Is like I think stability make the biggest difference. That make the team win. So therefore, in the final round, I keep talking to the team, don't make the things too complicated. The higher the complexity you have, the lower stability that we will have. So that will be a disaster. We have to always balance between this.
Nice. And that's the KISS principle. Keep it simple, stupid. Awesome. Yeah. Okay, so then can somebody walk us through, so what happens? So let's say a new target comes into your cyber reasoning system, right? A repository. What happens? Like, what does your system do? And maybe kind of walk us through the steps, maybe in relation to who worked on what, or I think it'd be super interesting to understand it from kind of a lower level.
Xinqian, you want to go?
Okay. So if a new task comes to the CRS, firstly, there will be a scheduler, which will like distribute between each components and send the task for to determine the task type. For example, is it a full task or delta task or a Java task, and send it to different types of components. For example, if we got a delta type of task, we will send it to some fuzzers, which including some general fuzzings and directed fuzzings. Yeah, because we have a delta, so we believe that delta fuzzing will help. Yes. And after some times of run, the fuzzers. Oh, okay. Yeah, I forgot one point that we will also do some like seed generations. Yeah. We have a seed generation based on LLM, and it will receive the repository of the task and then analyze the code and generate some initial seeds for the fuzzers.
And is this just like, here's the information, generate me seeds? Is it generating like a script that generates seeds? Like what kind of a style are you using there?
Yeah, we generate a script that produce some seeds.
Yeah.
Very cool.
Yeah, and then after fuzzing for a while, there may be some bugs that has been discovered, and then we will send the POCs to a triage component. Yeah, which will determine the type of the bug and to determine if the bug is is reproducible, and if there's a delta task, it will determine that if it is related to the delta. Yeah, because only in the delta tasks, only the bugs that related to task related to the delta will be counted. Yeah. Okay, and then after triaging, the patchers will receive this information that we found a bug, and we have the bug report. We have the sanitizer report, and then the bug will the patchers will try to patch these bugs.
And when you say patchers, that means you had maybe several patching strategies that you're trying to use?
Yes, we have different patching strategies. And also we will use different kind of models, like GPT or cloud. Okay.
Interesting.
Yeah. If some patches have been generated, we will do a preliminary test at our site. And if it's okay, we just send it to the competition server and to check the status. Yeah, because of because that if you send a patch to the competition server, it will also return the result of the functionality test. So it can also be an oracle for our patch for our patching components.
Awesome.
And also we have a dedicated handler for like SARIF evaluations.
Yeah, so I don't think let me just pause for 1 second, or can somebody remind our listeners what the SARIF reports were? I think we did it, but I kind of can't remember.
Okay, Xinqian, you can talk about it.
Okay, so I would say SARIF reports is a kind of like JSON which describes some static analysis results. Yes. And
that's right. Okay.
It may like include some information like the type of the vulnerability that it detects, and the code location of the like a buggy place. Yeah, and maybe there are some also like described of the bug in natural language. Yeah.
I see.
Okay.
Cool. Okay, so then you have a SARIF report and your patches. You maybe have generated a patch. So then, what happens basically next?
Okay. So there's a task called a SARIF evaluation in this competition. Yeah, the organizer will send our CRS some SARIF reports, and some of them are positive, but some of them may be false positives. Yeah. So when we receive the SARIF report, we will like also do some preliminary test. Preliminary analysis for the report, and to check to do some sanity check. If the file that reported in the SARIF report exists in our code repo. Yes, because they actually did this in the in the dry run round 2. They just they send a SARIF report to our CRS, which includes a code location that never exists in the repository. So it will definitely be false positive. But if you just feed this report to AI, maybe the LLM we think that it's like reasonable. So it is a true positive. Yeah. So the naive method is not acceptable for this kind of task. Yeah. So after some basic evaluations, we will move it to another component, which is code slicing, because we need to confirm that if the code locations in the SARIF report was reachable by the given harnesses.
Interesting.
Yes.
So more kind of sanity checking to see if those locations are even feasible.
Yes, because like in their rule book they say that although if a bug is if there is a bug and it was reported in the SARIF report, but it's not reachable by the harnesses they provided, it will be considered as a false positive. So we have this kind of check. Okay, so after this check, we will send these information obtained from the previous step to a directed fuzzer. Yeah, because we need. Yeah, we are in like yeah. Our strategy is that we will confirm that there is a bug and can be triggered by some POC, and we will confirm that this SARIF is a positive.
And those POCs come from the fuzzers, so it's like
Fuzzers.
you're trying to match the crashes then to the SARIF reports.
Yes.
Very cool. So you mentioned matching to the POCs to the SARIFs, so that confirms it fully. Then you do this. In the worst case, you basically ask the LLM with the reachability data, is this a real bug?
Yeah, I think yeah. In worst case, we will do nothing, because if you submit an error result, yeah, they will minus our points.
See, yeah. So then the strategy. So then, would you say that the system design, at least in this point, is affected by the game strategy?
Yes.
Awesome. Okay, so then what does the system do? And I think we maybe talked a little bit earlier, but as you're continuing to gather patches and crashes, like how does your system deal with that over time? So over the multiple hours
Okay,
of the
so
gameplay.
let's Ziyi introduce the patch deduplicator and reproducer.
Yeah, so actually, when we are working on the computation, we found a very challenging stuff is like, there are always many POCs comes from fuzzers, and actually it's pretty hard to deduplicate all the POCs. So, in the perfect scenario is like we can perfectly split all the POCs and we can divide them to all different bugs. But actually, in the real world, that's really, really hard and very challenging. So our policy is like we use patching stuff to do the deduplication, which is we generate the patch and we have a stage named patch deduplication, which means we use a patch and try to use this patch to fix different vulnerabilities in the same task. And we can say like, let's say we have vulnerability A and B, and if A and B is actually they are the same bug, so our patch can fix A and B simultaneously. So which actually becomes kind of like deduplication. And also we also observe sometimes the patch we call it a super patch. So a super patch sometimes can patch two different vulnerability. And also we observe that interesting stuff. Yeah.
Interesting. Can you tell us like what were cases where the LLM would create a super patch that would fix two like seemingly unrelated vulnerabilities?
Yeah, actually, I think we observed that from round 2. Let's say we found a ground truth bug, and also we found a 0-day, and we found like if we use our super patch that it can just simultaneously fix the ground truth bug and the 0-day bug. So that means this patch can simultaneous fix to different vulnerabilities. So previously, we think like the deduplication part is to verify if there is so is to deduplicate different POCs to a same bug. But after that, we found so sometimes the super patch may have different impact on it.
So the super patch has an impact, but if I was a open source maintainer and I received a PR that says this PR fixes 2 bugs, I wouldn't necessarily be upset about that. It could be even cool. Why is the super patch a problem?
Yeah, because that actually relate to our submission policy. So we always try to submit those patches that can cover the most bugs, which means we don't want to submit, let's say, two exactly same patches, which we think might affect our scores. So we always try to check if the patch can fix different groups of bugs or something like that.
So you guys try to submit the super patches?
Yeah, actually, in that round, we do submit the super patch. Yeah.
Interesting. How do you kind of digging into this a bit more? Because I think at some point, maybe I lost some piece of information. If I remember correctly, good.
Yeah, I would say that this design was also affected by the game rule. Yeah,
100%.
because like there was a kind of thing called an accuracy multiplier in the scoring algorithm, and if you did too many like inaccuracy submissions, it will significantly impact our scores. So, for example, if you have 2 ground truth bugs A and B, and you have 2 patches, patch A and patch B. In the general cases, you submit these 2 patches and got 2 valid submissions. But if you generate a super patch for one patch C, which can repair A and B, and then you submit the patch B again, you will receive 2 valid fixes and also 1 inaccuracy submission.
I see.
Yes.
So basically, the 2 strategies to deal with that are you either make sure you only patch 1 bug at a time, so you submit 3 patches in that case, or you submit your super patch.
Yes.
That's interesting because I think I don't remember if we got into this with Shellfish, but the Shellfish strategy was separating them as much as possible, so that to avoid the same problem, just a different solution to it. Combining them as much as possible is a really interesting thing. I wonder if there's more synergy there with the LLM's reasoning capability. Maybe it can start getting into the thought process behind the bugs. Did you see any of that?
Okay, so I would say, we have tried the strategy that separated each bugs, but we find that we find that our bugs in the definition of bug in our CRS may be different to the intended bug from the organizers.
Yeah.
Yes.
So like the super patch in this case,
When we are doing some evaluations on our own side, we find that 1 ground truth bug can produce like 20 or more than 20 different kinds of POCs. And in our CRS, it will be considered that like 20 bugs, and then it will be generated. It will generate 20 patches. Yeah, if we just submit this to the competition server, we will got like 19 inaccuracy submissions,
Yes.
which is horrible. Yeah.
And so for what you saw, and I wonder if doing more post-processing on this to try to, identify, we have this patch and they can be merged in their 1 bug versus their super patch if you merge them. Do you think that complicates the system too much? I've been thinking a lot about this KISS philosophy that Adam mentioned. I think in this case, it's not keep it simple, stupid, because we're using AI now, so everything is very smart. It's keep it simple and stable.
I think Dong have tried AI triage. Can you talk
Yes.
about that?
So like deduplication is a big thing for just for the scoring algorithm, right? So like we didn't do it early on, but we have to do it later on because they released the final scoring algorithm, and they have penalties on duplications. So at first, we try to do deduplication on the bugs themselves first, like not deduplication the patch, but deduplication on the bugs. And we try to use DARPA's provided deduplicator. It didn't work very well because
Which,
it's
if you
it's
remind
very
people, how did
naive.
that?
It's just a stack matching.
Yeah,
So
how did
we
they?
try
Yeah,
to
stack.
do LLMs to deduplicate bugs, and it seemed to work well in a few simple cases. But then later on, we found out that it has false positives. So when we give it two crashes for two different ground truths, it actually say that those two come from the same ground truth. And that will cause our patching agent to be super confused because like they are two different bugs. Like how can we fix it? It cannot fix it. So like
So
in the
instead, you
very
fix them
last
separately,
minute,
and then you try
yeah.
to merge them. Is that the correct
So in the
understanding?
very last, not last minute, but in the last round, like right after round 3, we decided that we don't do deduplication on bugs anymore. We put all of the crashes in the database, and we let the patch agent patch all of them, and then we do the post-processing on the patches. And so in this
Very
case,
cool.
super patch is not super patch on the ground truth. It's actually super patch on our bugs. So we have a lot of bugs, but a lot of them comes from the same ground truth. So if a patch can patch a large groups of those bugs in our definition, we believe that it is more probable that that patch is the correct one because it fixes a lot of the same root cause.
So this
The
is
risk-
really great because, yeah, exactly. Maybe we're going to say the same thing, Jan, but I think maybe what the people at home don't realize, because we didn't get into the rules at such a deep level, there was a temporal component to your score, right? So submitting a POC, you had more points if you submitted it early, similar with a patch. So did you use that trade-off of doing things fast versus waiting until you had enough POCs to generate a super patch to submit? And how did you kind of find that balance?
Yeah, we kind of did it on the interval. So we post-process patches on interval. Every interval, we test a patch against every POCs of the same bug. That is for the patch. But for the bug submissions, we just kind of give in to the rules. So the thing about duplication in bug submission, in POV submission, is that we are not penalized for duplication, but the submission that are taken into account is the latest one. So if we submitted multiple duplications, only the last one counts. And so we have a lower multiplier on time. But yeah, we didn't do anything about that. We just submit all of the POVs.
So, what about the risk of, I wonder if you ran into this. What I experience often with kind of LLM stuff in general is it works really well, but then if I give it too much data, the context window is too large, it like just gets overwhelmed and starts doing random stuff. How did you prevent that with the patch merging and the super patches? You probably have to process a lot more data because now you're reasoning about multiple parts of code, potentially multiple bugs. Did you find that effect at all? And how did you kind of bypass it if you found it?
We actually don't try to generate super patch. We
okay.
only give one crash report to our patch agent at a time. But if it happens to generate a super patch, because we have a post-processing to evaluate our patches, right? So if it happens to generate a super patch, then we submit it. Like we don't force the patch agent to generate a super patch.
I see. So you patch once at a time. You evaluate them based on the amount of crashes that they actually fixed, even crash that they didn't necessarily see. Okay, I think this is actually then, I misunderstood earlier. This is very similar to the shellfish route, because basically what you're doing in some sense is patch-based deduplication. I love this co-evolution. I mentioned this in previous podcasts, but I don't mean to say that your stuff's not impressive by any means. It's super cool, right? And everyone came up with this independently. The really interesting thing with the contests like the CGC, the Cybergram Challenge before this, and so on, right, is the convergent evolution of techniques that teams working in isolation for the same goal, being, completely without communication with each other, end up with similar things. It's really cool.
Yeah, and I think that the other thing is also the game rules, I think, force this a little bit, right? Because if I'm understanding it correctly, you're doing patch deduplication similar to how the organizers will do it at the end once they get everybody's POCs and everybody's patches, right? Cool. Yeah, so that
it's
that
a
makes
cool
sense
approach.
too. I will say the one big difference, at least that I've noticed, is that I think our SARIF strategy was just LLM it, and like that's it. Like I think that's it. Just LLM it. And the LLM, I think in our test was right 65% of the time or something, and so that's what we went with.
Yeah. There was another thought I had, but it's gone for the moment.
Yeah, I can add something more.
Please.
So regarding the LLM, so one thing that's very interesting to me is like after the first round, the DARPA actually released the number of bugs. So there is only one bug in the round one, and the DARPA basically released like which team find it at what time and how many duplications it generated. That's kind of data. And in addition to that, DARPA also released like the volume of tokens that has been consumed for the round one challenge. And one thing that really worry about us at that time is like we see like our usage of token is significantly lower than the average. It's like 2 times the magnitude of difference from the average. So we don't use that much, LLM tokens. And then they start to make us to think, do we actually design our system correctly? Should we actually put more stuff into it? And then we internally have discussions, shall we make a change or not? And at that time, our conclusion is like, don't do anything at this moment. So just keep it as it is. Maybe we will lose, or maybe this is not the best strategy, but we definitely would like to see how other team actually use LLM. But it's really surprising why they are using so many tokens. And I know some teams, they even complain to say, oh, the budget that you give us is not enough.
We need more.
But for us, it's like, oh, we still have a lot. It's not bothering us.
This is a great point, and this actually gets into the contest evolution from quals to finals, right? The quals budget was $100 in LLM credits for a specific target, and somebody will have to remind me. I don't know what the finals budget is, but it's significantly higher.
50,000 overall, or
50,000.
Yeah, that's quite a lot. Yeah, even like I do complain during the semifinal because at that time we have a kernel. I know like how much money we spend, how many tokens we need for kernel, and I talk to DARPA in the 1-1. I say like, oh, this is too less, so you should give more. And the answer they put back, they send me back is like, this is one of the challenges you need to deal with. And then at that time we start to think about how do we reduce the usage of the token, and then all of a sudden in the final they say, oh, we give you more, don't worry about it. But that's too late for us.
When you said round one, you meant quals.
No, the round one means
The exhibition round.
The exhibition round, yes.
Yeah, so for those that don't know, I don't think we went into this before. The final event had 3 practice events, basically. Exhibition round 1, 2, and 3. And these were, basically practice of the final round, because when you're building a system that needs to work autonomously, you can't just one-shot it. You need these practice rounds.
And not only we need it, but the organizers need it to build this infrastructure, and they need it to understand the game, and if the game is doing and the rules are doing what they want it to do, right? And or like this thing, what if they had such a small LLM budget that everyone hit the limit and the systems couldn't do anything? It's like that's not a good competition. So yeah, I think it's a very important design decision that they did for going from quals to finals, whereas quals was like the one submission is all you got.
Yeah, and it's very I think it's a good example of an evolution of a cutting edge challenge, right? We're not doing things like, hey, we've had decades of car races. Let's improve the car, keep the track the same. Both the track and the car are being built at the same time. Which is a very interesting situation to be in. It was the same, it's typically the same in almost every challenge DARPA runs, because that's how cutting edge these challenges are trying to be. And so that's interesting in the difference in LLM use. And this, on this note, I just want to ask real quick, what's your favorite AI as a team?
That's what I was going to ask, man.
Dang,
not even as a
there first.
team. I think there's interesting
Even
things
individually.
here. What is your
Patching,
system
CTF,
using?
yeah.
Exactly. What did you find is better at what thing? What do you personally use? Let's maybe start there.
Do you want to go first?
Yeah, I think so in our system we evaluate different models, and we finally pick the GPT 4.1 and the Cloud Opus, which we think they are the most powerful. And also we have an evaluation of that. So the Opus reaches the highest repair successful rate to our cases. We have kind of like a data set, so we do the evaluation. So the Opus I think reaches the highest successful rate. And also Sonnet Sonnet is a good one because it's really quick and relatively not such expensive. Yeah.
Yeah, in my opinion, so it's really hard to answer which model is the better. The reason is it really depends how you use it. If you want to give a lot of information to AI, Opus is not a good idea because the Opus have the smaller context window. It's not a good idea. And if you care about the budget, so say, for example, in the semifinal, we only have $100. We even try Haiku. Haiku is cheaper. That is one of the cloud series model. It's cheaper, but it's very, very efficient. But the accuracy is not that good. But you can try multiple times and increase the accuracy. But still, the cost of using Haiku is low. So it really depends on your strategy. And but overall, if the budget is not your concern, and you only care about the accuracy, and I think Opus cloud model in general give you better performance than OpenAI. But it really depends on the task. So if you are trying to understand the code, I would say like OpenAI is better. Or using the model to call different tool chains, OpenAI is doing better job. It really depends on the.
Looks like there's some room for scientific measurement here.
I was going to say it's a very professor answer. I really liked it. So also,
okay, but
similar response if somebody asked you who your favorite PhD student is. Like, well, they're all good at different things. So it depends on the task and the context.
We all know that's not true. But, yeah, no, I'm just kidding.
Wait, I want to hear from everyone else. Dang, what about you?
Yeah. So I guess, again, it depends on the task, right? For patching, at the end, we use Claude, Opus, and GPT 4.1, but we use more Claude than GPT 4.1. So we set like more budget for Claude. But for example, for Xinqian, we use a lot of different models because more seeds is better, right? Just if
That's
like
brilliant.
the different models, we generate a more diverse set of seeds, and that will be more helpful to fuzzing overall. So we just use all of them. We run them all in parallel. So
Nice.
we run O3 Mini, we run 4.1, we run 4.0, we run Sonnet. I just run all of them in parallel.
Nice. So then is your patching strategy also like running those models in parallel to try to generate patches, or is it like serial but using one more than the other based on your budget?
We do run patch agents on parallel, yeah. We have, like, let's say, I don't remember exactly the exact amounts, but like 8 to 1, like 8 Claude to 1 GPT, something like that. It's not the exact number, but yeah.
All right, Xinguan, do you have, what's your favorite? You have to pick one. If I made you pick one AI model to use for the rest of your life right now, which one would it be?
Oh, yeah. If you see in my daily life, I will pick Gemini because I have
Ooh.
many many smart devices in Google Home. So yeah, it can be so Google Home can be a tool core of the Gemini model.
Nice. I like
It's
it.
very
Cool.
convenient.
So in a future episode of CTF Radio, we need to do Marry, Love, Kill of AI
With
models.
the models?
With the model. It would be awesome.
Yeah, our team was like highly Claude. We were very Claude and Anthropic. The credit
We
card
had a Claude stuffed doll, it turned out.
Yeah, the Claude ant, I believe. Is that what the... Or Anthropic, I guess that makes sense of why that's an ant now that I say it out loud.
Yeah, the question
Never
that you
got
guys
that.
ask is very risky because OpenAI people and Anthropic people may watch this and then it's basically block us to work for them in the future.
Exactly. That's what I was thinking.
I don't know. I think you want the critics to work for you. That way you can make the models better. And I'm sure you already said that you have great test sets and data sets that you've used to evaluate these models. So you understand what they're good for and bad for. And I think the other important thing that nobody stated, but we should keep in mind, right? This is a snapshot in time, right? These models are continually being updated. And actually on that note, maybe you can talk about what did you see in the difference in the models from quals to finals?
Yeah, we try basically nearly all model for the past years. And at that time, I think, if I remember correctly, that was Cloud 3, 2.7, and then 3, and 3.1, 3.2, 3.5, 3.7, and we try all of them. One thing that made me start to believe AI will be a game changer in cybersecurity is I observe it becomes smarter and smarter. So at the beginning, I basically don't trust AI at all. To be honest, the first day when I see this competition, then my first feeling is like, let's use traditional approach to deal with it.
Mm-hmm.
But after the more that we try AI and after the AI got evolved, then it start to make me to believe like AI can definitely do something and which can even do better job probably than our human. And I do see there is a trend of changing significantly. So I'm so happy to see that. And I hope this is my on my wish list. I hope some days I can work with OpenAI, Anthropic, or even like xAI, any large model companies, and we can work together to make their model better because we have a lot of insight. We know like how to make them better. But hopefully they will hear what I say and then contact us.
Great.
It's super cool because it's very similar. I have a feeling we're gonna hear something along these lines from every team. Is like, holy shit, this stuff got good.
Yeah,
And I agree. Like back when the AIxCC started, it was like, you want us to do what?
yeah, it's wild. And I think maybe the thing, I can't remember if we asked Will and Lucas about this, Jan, but the one reason we didn't use Gemini in our system is because we were never able to like get our limits set high enough to actually test it in our system. And so we just used Claude. So I'll be super interested if a team was able to bypass these like weird hurdles that are involved in using these models and was able, and a team says like Gemini's the best, like hands down.
Oh, and interestingly, there's the Sec Gemini that came out recently, right? So I don't know if it's API queryable, but that might have been an interesting thing to investigate as well.
Cool. Okay, so I'd like to go back to kind of the architecture design because I think it was Dang you mentioned the database. The seeds get put in the database. So did you have like a centralized design? There was a central database. Was something like I think somebody mentioned a scheduler too. Was it coordinating all these various tasks and things? So can you talk to us about that level of design?
Yeah, we do have a centralized database, and we do have a kind of centralized scheduler that would send tasks to different components. We don't believe that it's the best, but that is what we went with at the beginning. And so,
is
like,
it custom written, or did you pick something off the shelf?
The database? Is that your question?
No. The scheduler.
The scheduler, we wrote it ourselves. Yeah. So, like, halfway through the competition, like right around after round one, we have some discussion on the overall infrastructure because after round one, we found some issues with this design. But like at this point, we cannot change the entire system. So we just went with it and tried to overcome those difficulties with that design. But yeah, we do have centralized things. We don't believe that it's the best, but that's what we went with.
Nice. So can you talk about what some of the maybe either it could be engineering trade-offs of that centralized design. It could be social trade-offs. Like I can tell you about the Shellfish system briefly, but I'd love to hear from you guys what like kind of those lessons learned were architecturally.
Yeah. So the way that the scheduler communicate with other components is through RabbitMQ. We choose RabbitMQ because we knew how to use it from the semifinals, and so we just keep using it. But then we realized that it kind of gets messy, and if we only host one part for RabbitMQ, it might, like when the system scale up to a certain point, then it might overload that part.
I've never seen a RabbitMQ deployment I didn't regret.
Yeah, we kind of regretted it, but it is what it is.
Yeah,
So-
at some point you just got to make it work.
Yeah, because we really cannot test with the scale that we will use for the competition rounds, right? We don't have that much budget during testing, so we don't know if we scaled up to that point, can RabbitMQ survives. So, yeah. But yeah, so, and also we not only have RabbitMQ between scheduler and components. Later on, as we develop new features, we want components to communicate with each other, and now components are creating more RabbitMQ connections, and so it's just get messier and messier from there. Yeah, we're just happy that finally we make it work somehow.
Well, I think that's honestly, it's actually at a high level, it's very similar to the Shellfish design. I mean, we designed because we're insane, we designed our own custom orchestration, and it's kind of like almost like a DAG where you have components that accept inputs and generate outputs, and then once those outputs are ready, like the component magically gets started and you can specify all this kind of stuff. But I think so we don't have a centralized database, which scares the heck out of me, especially with some of the bugs that we found in our custom crazy framework. But I think essentially you have exactly the same problem. Like, you have a component, they need to, like, somebody needs to ingest the output of another component, right? So you need some kind of interface, and then exactly like you said, like, okay, but now other people need to use that, or somebody in the middle is changing their component, and now the downstream ones get, like, either they break or they need to get fixed. And so yeah, you guys, it sounds like just using queues as your messaging system between components while having the data stored in that centralized database.
And anything else you would have tried would have run into some issues, right? In the CGC, we had a centralized database that implemented our queue. We had a job stable and a blah that had a lot of issues.
Yeah,
I think there's just one of these kind of unsolved problems in computer science, and anyone that claims that they have it solved has it solved for their specific toy use case that they struggle to have it solved for. Then you adapt it, and it turns out it's shit.
Yeah. So basically, we, instead of trying some new things and get new issues, we just try to fix our current issue, basically.
Well, yeah. I think everyone has to make that call at some point. Like, you just have to make this stuff work. I mean, kind of like you said, the keep it simple and stable philosophy, trying to pivot away, like months before the end of a 2-year competition, that's risky. So in terms of system design, we talked a lot about patching, we talked a lot about deduplication of crash, we talked a lot about seed generation. We haven't talked a lot about the fuzzing itself. So you use kind of this AI assistance to generate initial seeds for fuzzing. You use AI assistance to think about the resulting crashes. What does that fuzzing component look like?
So I can talk about a little bit about fuzzing because our fuzzing people is not here. So basically, for the fuzzing, we just use the fuzzer existed fuzzing framework to do that. The only thing that we have like AI into it are two. There are two things that we introduce AI. Number one is the seed generation, which we talked about earlier. But more importantly, is like we're basically leveraging a machine learning algorithm called reinforcement learning, which basically combine all the fuzzers together. So if we take a look at the fuzzer, particularly the research paper, the tools, there are just so many different research papers, so many tools out there. But different tools have different advantages for different target. Some target you may consider using tool A, some target you may consider use tool B. But given the computation, you have no idea what kind of target you want to see. So therefore, our strategy is basically integrating all the fuzzers together and have a algorithm to schedule which fuzzer should be allocate more resources while doing the fuzzing. So we are basically doing that. And even in the before the semifinal, we test this approach on a Google sponsored fuzzing competition. And we win the champion using that strategy. We beat AFL++, and so on. And it's doing really, really good. And then they start to make us to believe that this is the strategy we should use. So that is basically about the fuzzing. We don't use too much LLM over there, but scheduling using AI, that is the key to make the fuzzing more efficient and have better coverage.
So scheduling
Nice.
using AI is interesting. Why schedule? Like, you can imagine a world where you have infinite compute. In that case, you just spew out a ton of fuzzing jobs. Why schedule in the AIxCC?
In AIxCC, the budget is bounded. It's not unlimited resources. But of course, if we have unlimited resources, we are happy to, we don't need to worry about the scheduling. But because of the limited resources, we have to use that resource carefully. And we cannot, so we trust some of the fuzzer is better, but we cannot fully trust that. Therefore, we will have adaptive, adjustment while the fuzzing is carry on.
Very cool. And so what were you using as the feedback loop for the reinforcement learning algorithm? Was it seeds discovered, like interesting inputs, or is it crashes, or were there, I don't know, maybe even further downstream, like patches that came from that crashing input?
Okay, so this is a good question. So the strategy, the feedback is actually complicated, but the high level idea is like this. So I will use analogy to explain what happened. So let's think about, we have 6 people right now here, and each of us have different expertise. And right now we are taking a math contest. So we have math question, and different people have different expertise. But for some simple question, everybody could do a good job. But when we are seeing a hard question, so it's going to take some of us longer time and some of us shorter time. So we, based on the difficulty of the challenge and how quickly each of the father will be able to solve that, then we will give higher, more resources to that father. So this is dynamically adjusted based on the difficulty of the target and also the time needed to address that challenge.
What I don't like about this is that in this scenario, Adam would get all the resources.
It's definitely not true. You're way more mathy than me. Yeah, and particularly, I think the other super interesting thing there. So then, do you then, that kind of inherently deals with the saturation problem? Kind of when you've saturated one fuzzer of inputs, it kind of reverts to trying the.
Yeah, if we saturate at some time, then we will basically rearrange the resources. We will randomly uniform distribute the resource.
Cool.
And so that we can balance.
Nice. Yeah, that's awesome.
We have a paper about that, so we will make that paper available. Even like patch agent, we submit paper to Usenix before the competition, the final round.
Yes. You also got it accepted before the final round.
Exactly.
But I noticed it wasn't available until the submission deadline passed.
Exactly. Yeah, I talked to the chair. I say we don't want to make this public available. And the chair said, okay, I will put that into, restricted access.
Nice. Very cool. Awesome.
So from, Adam, do you want to move on from the technical stuff?
Yeah, I think it's probably time.
So, actually, one more technical question. That's right. Out of everything you talked about, and including things we didn't, maybe we forgot to touch on something, what is the biggest secret sauce of 42 Beyond Bug?
That's a good question, but it's not secret sauce if I say this, so it's nothing, basically. I can definitely share it. The biggest secret sauce is stable and putting more resources on testing. That is the secret sauce. That is the only secret sauce that I have. So I'm the one who's trying to convince the whole team stability is the number one. Although many of them doesn't agree, they want to do, cutting edge research and they want to try these and that. They say, I basically get the paper every day from my team members. And they send me paper to say, hey, I see this paper and this published here and it's doing great. We should try this. And I'm the bad person in the team to say, stop doing that and focus on the testing, keep it simple. So I would say the secret sauce for the team is testing and, stability. So that is the secret sauce. I don't think like we are outsmart than other team. Like basically like teams, all the team probably is going to be the same, have the similar solution, and some team might have a better, but if you don't have stability, everything is zero. So stability is definitely the most important things from my viewpoint.
There's a very clear secret sauce from what you just said. It's you. You
That's right.
created the team, and you have it's all people that you work with, that you have worked with in the past. So your convincing arguments were probably much more likely to land than if it was a random team member doing that.
Thank you. Thank you so much. I'm so happy to hear about that. Thank you.
No,
Awesome.
that's great.
Moving on, I have a quick, if you look at the total amount at stake in the finals, it's like $8.5 million or something, right? There's 7 teams, so the expected value, if everything was random, everyone's so good that it's just going to come out down to luck. Everyone's winning over $1 million. What are you guys going to do with the money?
Wait, stop. Before that, sorry, Jan. Before that, what place are you predicting that your team will make?
Oh, that's very hard question, to be honest. So when we decide to participate, our goal, of course, everybody would love to win. But I say this, I literally mean it. My goal of doing this is trying to explore. This is a great opportunity. I want to explore. At the same time, learn from other team, and also gather experience from that. And this is the most important things. At that time, I have no idea like whether we will win or not, but we put 100% of time, our effort on that. I don't know how to answer this question. This is really, really hard. I hope we can win. But at the same time, I really mean it. I hope all the team will learn something from this, will get benefit from it, not just the dollar they take back home. Because money is important, but it's not the only important thing for this competition, in my opinion.
The real prize is the friends we make along the way.
Yeah, exactly. Like you guys, I really enjoy like every time I talk to you guys. For the people who are watching this, they probably don't know. Like I have very good relationship with Adam and Yang. We have a lot of research paper. We publish a lot of research paper together. And so this is a fantastic friendship. Yeah, and also this is a great opportunity to learn, from other team and get impressed by, a sponsor, the vendors who sponsor the competition. So that is all much more valuable than taking the money back home.
Yeah, exactly. I think that's great way to, phrase it. And also I think the other thing that'll help that learning aspect is the fact that all the teams are forced to open source their systems. So you will be able to learn from all the systems. And if somebody does have some crazy new design or technique, or their patching system is just off the charts crazy good, like we'll all be able to learn from that and go forward.
Exactly. Totally agree.
All right, but assuming you do win, back to Jan's question, what are you going to do with the money?
So for us, if we could have the money. What we will do is we're probably going to continue. Not probably, I'm 100% sure I will continue along this line. More specifically, I would like to, like what I said, during this whole journey, we accumulate a lot of insight. We have a better understanding about the model. We have better understanding about the cybersecurity. And we think we probably know how to make their model better. We definitely would like to work with the vendors like OpenAI, Anthropic, xAI, like with Gemini. We would love to work with them to make their model better. But to do that, it needs money. So the API have the cost, the infrastructure has cost, GPU is expensive, and students who want to work in this product would need to get support. We want to use the money for that purposes. That is how we plan to use them.
Nice. Yeah. As I can definitely share this because I can do it. But in the lead up to submission, I think we were using roughly 5,000 in Anthropic credits a day on our internal testing and stuff. And so I just kept seeing like the credit card charges coming in. But like, it's like, hey, you got to, like you said, you got to test this stuff and make sure that it's working, right? Or that changes that you're making don't break.
Exactly.
And that's not even counting compute.
Yeah. Actually, the testing is very expensive. So it's cost us like 30% of the budget. Not so that's very, very expensive. So my credit card, so at the beginning when you are using API, so you are in the very low tier and quickly go to the highest tier, and then they handle your request very serious. It's very expensive computation, to be honest.
Yeah, exactly. Which makes sense of why DARPA, they're not just funding it just to like incentivize people to do this, but it actually is an expensive competition to be in. I posted in the channel, we had like a $26,000 Azure bill that came in from all the tests that we were running towards the end. It's just kind of wild when you look at it like that. Awesome. Okay, so we're getting kind of close to the end. I have a little bit of a social question. So as an academic team, how did you feel like competing in this kind of not academic kind of competition, right? It sounds like you're getting papers out of it, which is amazing. But how did, I guess, the team members balance the PhD with the competition?
I think it's better have the team to answer that. So if I answer that, this is my feeling. So I do watch for quite a long time to convince them to compete. But I really want to hear their real thoughts. Dang, you want to go first?
Yeah, sure. I mean, I am a bit anxious about not getting papers out for 2 years. I mean, I did got some paper out for the first year because like those I worked on before AIxCC. But yeah, it's pretty anxious for me to not have papers out. But then again, I think this is a great opportunity and everyone is giving their 100% for it. So I'm just going along with it, see how it goes. And because like as Xinyu promised, and I'm also pretty sure we can make some paper out of the ideas that we had in this competition. So it's not like a complete trade-off, right? We still have something out of it afterward. So yeah.
I'll keep my promise for sure.
I love the dynamic on display. I think it's a very cool team dynamic. I think Adam mentioned it earlier too. It's great.
So Xinqian, you want to say a few words?
Okay. So just like Dang, and I also like devoted almost all of my time to the AICC, and was also anxious about the papers. But when they after our submission, we look back to our journey, and we found that there are many things that can become some research ideas. So I think that will also benefit our like academic studies and researches. Yes, and when we are doing the development, we also found that the current solutions for like fuzzing or some other things are very limited, and this will also like inspire us for some new ideas for academic researching.
Nice.
Ziyi, you want to say a few words?
I actually think it's a really good opportunity because for AICC we have opportunities to dive in the whole system and try to think in depth, like how can we use LLM for the cybersecurity. And I do think there are many tasks and many interesting problems that we can explore, and we also we have seen some interesting problems, and we will maybe publish some papers for that.
Yeah, I want to add one more thing.
Please.
So although like most of students, the research paper is definitely important, and doing fantastic research is important for the student. But along the journey, there's one thing that we will never ever gain if we don't participate. That is the soft skill. Because at academia, we will never ever have a chance to work to coordinate so many efforts, in one project, and making sure like we have to trust each other, and so on. So only in this AICC journey, for our students, we'll be able to, learn from this journey, know how to trust each other, even though sometimes we have a strong disagree, but we know like we are not going to fight. So we will, work together, we will communicate, and making sure like everybody's on the same page. Those soft skills will never be ever to pick up if in academia, but this AICC journey give us that kind of chance to cultivate our students to let our students know how to work as a team and trust each other.
Yeah, that's great. I mean, that's definitely echo all of those. I think the other thing is like this is maybe a once in a PhD opportunity, right? So like not every PhD student gets an opportunity like this to compete in a competition like this. So I don't know. And when we were talking to our PhD students, I was like, are you guys crazy? Not even like thinking like, I don't know. I'm just like, heck yeah. Like if this was happening like when I was a PhD student, like jump right in. Although I guess on the flip side, you guys were doing the CGC, but in my defense, I was graduating. So I said, no, thank you. I do not want any part of this craziness.
Yeah, the team building, that exposure to what that need to deliver something real and functional is, for me, it was life changing in the CGC. I mean, it's actually the reason I became a professor. I wasn't planning on academia before that. CGC, supercharged that. So I think, you have to give up some papers during the thing, but you get that return on investment. It's going to be awesome.
Yeah, so this year our team have the lowest number of publications across my entire career. But I think for me, I think it's worth it. So we are currently is catching up. So we hope like we could publish.
Exactly. Same, it's very, very similar. And it just makes sense. It's an opportunity you have to pursue and you want to do it full throated. I think that's the other thing is like, you don't want to look back and be like, oh, well, I published that one paper, but man, I didn't give everything I had to AIxCC. Like, I really wish I had gone back. So speaking of on that note, is there anything now that you've done this 2 years later, looking back, what would you have done differently? And it could be anything, technical, like, I don't know. Is there something you look back and like, if I could do it all again, I would probably tweak this thing?
That's a good question. So I definitely think about this in the past. The key here is because at that time, even like right now, we have a shortage of budget. For me, I really want to touch the model, and I think I know how to do this, make it better. But the thing is, like academia, even like this much of a prize money, is not enough for us to run the GPU. That is the biggest regret that I have. If I can go back, I really want to.
You're in luck because probably right as this airs, a meta recruiter is gonna kick down your door and kidnap you into their new AI team.
Please, they should do it.
Anybody else have thoughts on things they'd maybe do differently?
Xinqian?
Okay, so if I go back to 2 years later, I will say like I should embrace AI earlier. Yes.
Nice.
Because after the semifinal, we started to trust AI and use AI in all components. But if we find the potential of the AI earlier, I think we will do better.
Nice. And especially now that Gemini is ruling your entire home. So you definitely need to get used to AI.
Yeah, well, nothing really comes to mind for me.
Perfect
I was
experience.
also an AI hater 2 years ago, but yeah.
I can't tell if this is the perfect response for a tester to say that like, nope, I would have done it all exactly the same thing. So yeah, that's great. What about you, Ziyi?
Yeah, I actually agree with Xinqian because I think I should also embrace AI earlier. So so dating back to 2 years ago, so at that time I'm kind of like so I usually like those traditional techniques and very complicated to solve the problem, and I didn't expect using AI will change that much, but after AIxCC, so we all know the power of the LLMs. Yeah.
Yeah. And by the way, I completely pivot our team from traditional. So my team originally do some AI. I know in your team, I have one graduate student in your team.
Yes, our one spy.
Yeah, he's really good. And but I do AI for many years, and but at that time my strategy is like separate two group of people who work on AI, they work on AI, people working on traditional things work on traditional. They talk to each other but not that intense. But after AIxCC, So I completely merge them all together. So they have to work, everything have to relevant to the AI. So that is the biggest change.
Very cool.
That's great. All right. Well, thank you all so much for joining us today. I think this was really, I learned a ton, so I really appreciate that. All right. And so now it's time to say goodbye. So thanks for joining us today on the podcast. So I'm Adam D. You can find me online at Adam Dupay. He's Zardus. You can find him online at Zardus. Together we are CTF Radio, and you can find us online at CTF Radiooo. Take care and happy hacking.
Thank you so much for having us.
Thank you.